Hi everyone, welcome back. Today we'll be looking at standard 6.ns.b4. Use the distributive property to express a sum of two whole numbers ranging from 1 to 100 with a common factor as a multiple of a sum of two whole numbers with no common factor. So we'll be working with distributive property that involves no variables. Our variables will come into our next lesson. Now I want you to think about this whole concept of distribution. Here we have a grain factory, and it's going to be distributing some amount of products to each of these warehouses. So they'll send some grain to the first warehouse, some to the second, some to the third, and some to the fourth. Now, if you take a look at the variables that we have listed here, so we have C, open parentheses, A plus B plus D plus E, closed parentheses. Whenever you see parentheses and a value on the outside, it's representing multiplication. So to use the concept of distribution, I can say that I'm sending C, it could represent my grain, out to each of these factories. And when we distribute in this manner, that operation is multiplication. So I'm pretty much saying C times A, C times B, C times D, and C times E. Let's take a look further at this. Our vocabulary terms: distributive property. Multiplying a number by a group of numbers added together is the same as doing each multiplication separately. Commutative property. You can swap numbers around and still get the same answer when you add or multiply. Order doesn't matter. So if I'm adding 2 plus 5, it's the same as adding 5 plus 2. Or if I'm saying 2 times 3, it's the same thing as saying 3 times 2. Now let's take a look at this. So here we're going to actually break down some numbers and then apply the distributive property. So how can we express the following examples using the distributive property? Now, if I take a look at 74, 74 is a big number, but I can break it down into tens and ones. So if I break it down into tens, I have 7 tens, which is 70, and 4 ones. Okay, so that's being added. And I'm going to now multiply that sum of 70 plus 4 to 74. So I'm going to rewrite this with the 3 on the outside, and I'm going to use my parentheses because we like to use parentheses when representing distributive property. And I'm going to put the sum on the inside. So I can represent 74 times 3 as 3 times the sum of 70 plus 4. Now, if I were to distribute, you would see that we would get the exact same answer. 74 times 3 would be exactly equal to 70 plus 4, and then times 3, or 3 times 70, 3 times 4. So if we were to apply distribution here, you would have 3 times 70 plus 3 times 4. And if you do the multiplication and then add, you'll see that your answers are the same. Now let's take a look at 9 times 5. If I wanted to break up the number 9, I can split it into 5 plus 4. And now I can multiply that sum by the 5 that's being multiplied here. So 5 goes on the outside, and then I can rewrite the 5 plus 4 on the inside of the parentheses. You could have also written this as 5 plus 4, and then have your 5 on the other side of the parentheses. Either way is acceptable and will get you the same answer as long as you distribute correctly. But we like to write it where our number on the outside is first, and then the sum is inside the parentheses. Okay? So to represent 74 times 3, using distributive property, we would need to break up the 74 and then use multiplication to represent the numbers. And the same for the 9 times 5. Here are some steps for factoring out a GCF when I have two numbers that maybe I want to take a different approach on. So how can I represent the sum of 36 and 8 using the distributive property? So my first step is to identify the GCF. So what is the greatest common factor of 36 and 8? 4. If you said 4, that is absolutely correct. We've seen in a previous video how to factor. If you don't know how to find the GCF, see my video on greatest common factor. So here we're factoring out the number 4. We would write that as 4, open parentheses. So now 36 divided by 4 is 9, and 8 divided by 4 is 2. So 36 plus 8 can also be represented as 4 times 9 plus 2. Okay, now let's actually go ahead and apply the distributive property and see what this looks like. So 36 plus 8 is equal to 44. And when I apply the distributive property here, I get 4 times 9 plus 4 times 2. Now let's go ahead and calculate that. 4 times 9 is 36, exactly where I started. 4 times 2 is 8, again. And when I add those two numbers, it's equal to 44. So did it work out? Yes, it did. And I can do a check. Step 2 was to write your answer as a product of the GCF and the sum of the factor pairs. So even though we went ahead and calculated it here, our final answer would be represented as 4 parentheses 9 plus 2, because we're being asked to represent the numbers 36 plus 8 as a distributive property problem. Now let's take a look at two additional examples. So I have 49 plus 7, and then I have 21 minus 15. I'm going to follow those same steps. So my first step said to identify the GCF. What is the greatest number that can go evenly into 49 and 7? Did you say 7? You're correct. So let's factor out that 7. So 7 times what number is equal to 49? 7. Yep, 7 times 7 is 49. Now 7 divided by 7 is 1. So writing 49 plus 7 as a distributive property would be 7, open parentheses, 7 plus 1, closed parentheses. Okay, and we would read this as 7 times the sum of 7 plus 1. Now let's do the same thing for 21 minus 15. What is my greatest common factor here? This is a good place to pause the video and actually think about this problem. If you said the number 3, you are absolutely correct. So 21 divided by 3 is 7, and 15 divided by 3 is 5. So here, my final answer is 3 times the difference of 7 and 5. Okay, so here it is. It's not asking us to solve it. I know a lot of times we want to actually go and solve the problem, but this is what it's asking you to do. Rewrite the problem using the distributive property. And the distributive property is this whole concept of having a number on the outside and being multiplied by either the sum or the difference of another number. Now we're seeing some other examples. The instruction here says, simplify the following examples using the distributive property. So the whole concept of simplifying is pretty much telling us to solve. So here we're going to apply the distributive property. Again, as I showed you previously, whenever you're using the distributive property, you want to show those arrows. So that 8 is going to be multiplied to the 3, it's going to be multiplied to the 5, and it's also going to be multiplied to the 2. So let's go ahead and rewrite that. So now we have 8 times 3 plus 8 times 5 plus 8 times 2. And this is pretty much going back to the definition, right? So it pretty much said I could have added all of these, so 3 plus 5 plus 2, and then multiplied by 8, and I should get the same answer as if I multiplied each of the values inside the parentheses by the number on the outside. Let's go ahead and solve. 8 times 3 is 24. 8 times 5 is 40. 8 times 2 is 16. Now let's off to the side just add these up. So 24 plus 40 plus 16. I should put my plus sign a little further down. So 40 and 16, and then the plus sign. 4 plus 0 is 4, plus 6 is 10. 2 plus 4 is 6, plus 1 is 7, plus 1 is 8. So all of these numbers added together is equal to 80. Now let's see if it's the same as if I added everything in my parentheses and then multiplied. So 3 plus 5 is 8, plus 2 is 10. And that's being multiplied by 8. 8 times 10 is indeed 80. Okay, so we see that our answer is correct and the rule does make sense. Now let's go ahead and take a look at the next example. So here we see 5 parentheses 7 minus 3, and we're going to do the same thing. We're going to use those arrows to show that we are multiplying the 5 through to the 7 and the 3. And a lot of you are going to say, oh, I don't need to draw those arrows. But I will tell you now, a common mistake is to just multiply the 5 by the first number and completely forget about the second number. So drawing those arrows serve as a visual reminder that you need to multiply both numbers, or however many numbers in the parentheses, by the number on the outside. So here we have 5 times 7 minus 5 times 3. All right, let's go ahead and multiply. 5 times 7 is 35. 5 times 3 is 15. So now 35 minus 15 is equal to 20. Let's see if we'll get the same thing if we did the operation in the parentheses first and then multiplied, which is what we were told to do using order operations. 7 minus 3 is 4. Bring down the 5. 5 times 4 is 20. So it absolutely works out. But would I have gotten credit for doing it this way? 7 minus 3 is 4 and then multiplying it by 5? No, because it's asking me to use the distributive property. And the distributive property requires me to distribute the number 5 through to each value inside the parentheses. So this over here is what would have given me full credit for this work. Thank you for watching and have a wonderful day.